So the project that we've been doing for AUTO21 relates to improving the use of sort of modeling and simulation and digital human models to analyze workplaces, specifically automotive workplaces, well before they even exist in reality. So we're trying to improve both the process of doing that, but also the sort of biological fidelity of the models that are used to predict things like shoulder strength or the loads on the back. And try to sort of understand how people do things as well. The costs associated with bad ergonomics aren't just people getting injured and compensation claims, but it's also that when you're tired or hurt, the quality of your work goes down, and there's lots of costs associated with that as well. The two biggest advances we've had related to this work is one, I think we've come up with a completely new way to analyze the capabilities of the upper extremities, so shoulders, elbows, hand, wrist, which is really almost every job that gets done in an assembly plant at some point puts demands on the arms because it eventually gets done with the hands. One of the problems in ergonomics is that we can analyze task A or analyze task B and make decisions about those, but we're starting to develop methods that will look at the accumulated effect of doing, let's say, a hand grip and then a push with your thumb and then pulling on something and then using a hand tool. We can actually try to track how that will fatigue the different joints and see whether the accumulated effect of those tasks are acceptable, and maybe help determine what the sequence of tasks might be that would be more optimal to avoid that, or how tasks should be distributed within a large assembly plant to optimize the capabilities of the workers and reduce the fatigue.
The field of ergonomics is relatively new, and within the automotive sector, we do a lot of planning. And so using the research that was collected in Dr. Potvin's lab through the AUTO21 support, we've been able to improve its ability to predict injury risk. So he's done a lot of work on the strength capabilities of humans. So we then can integrate that information and to understand how much is too much. How much can we have someone do on a repetitive basis? So we've seen a dramatic improvement in our back injuries, and I credit that a lot to the researchers who are giving us the tools to make these good decisions. So in particular, I'm really excited that we've used a lot of the digital human modeling and the planning and these new strength data in the launch of the new Edge at Oakville Assembly Plant. So we're really excited to work with AUTO21. I really am passionate that good research is addressing the needs of industry. And in this case, that relationship that we have with Dr. Potvin has been key.
I think working from sort of the inside out, it's definitely going to benefit workers, because I think we've been able to design jobs that are more in line with their capabilities, and we can accommodate a larger percentage of the population, such that people don't go home with undue fatigue or discomfort or pain. They have a quality of life that they can maintain. But I also think it makes the companies like Ford more competitive, and I think it helps ensure that Canadian automotive manufacturing can be healthy and still be a part of the manufacturing sector in Canada.